Hello everyone. In this session, I'm going to explain the microcontroller and embedded system lab program. Code is 18CSL48. I'm going to explain the first hardware lab, that is displaying hello world message using internal UART. Okay. For this, we are going to use ARM7 TDMI LPC2148 evaluation board. Okay. Uh, this is the overall code, how we can use the internal UART to send hello world message. Okay. Before that, I'm going to I will show some video where you will understand what is serial communication. Okay, and how we can send the data in using UART. Okay, please listen to this video.
So what is a serial communication protocol? Well, it's a way of transmitting data in a line, one data after the other, and in this case we are talking about digital data. Imagine that you want to send the number 198, which in binary, which are just ones and zeros, will be 110000110. You could connect a wire for each bit and send the high digital pulse for ones and the low value for zeros, and do that at the same time. So in just one moment you can send all the bits at the same time. This is called a parallel communication. The downside of this kind of communication is that we have to use 8 connections plus the ground reference, so a total of 9 cables. But this is for 8 bits. Imagine that you want to send a 16 bits data. In that case we will need 17 cables, and usually we want fewer connections. So instead of sending the data each bit at the same time, what we will do is to place the bits in series, and then we send each one after the other using just one cable. But you could already see the downside of this type of communication. If we send 16 bits in parallel, we need only one clock pulse to send all the data. If we send the same data using serial communication, we will need 16 clock pulses to send the same amount of data, so this will be 16 times slower. So that's the main disadvantage of using serial communication. As examples for serial communication, we have the S-Bus, the PPM, the JTAG connection, WART, I2C, the CAN, SPI, MIDI, USB, RS-233 and more. And even the Morse code could be a serial communication. Okay guys, so we have mentioned that clock pulses before. Depending on this clock, serial communication could be synchronous or asynchronous, and the main difference is that one uses the clock to send the data at a specific speed and time, and the asynchronous doesn't have a clock. So how do you know where one bit will end and where the next bit will start, if you don't have any clock? To understand that, we start with the most basic asynchronous serial communication, UART or Universal Asynchronous Receiver Transmitter. This type of communication uses only one cable to send the data plus the ground reference. The transmitter cable will be named TX and the receiver will be RX. The transmitter starts sending bits whenever it wants. So how does the receiver know when the incoming data starts, where it ends, when we have a bit or the other, and so on? For that, UART communication will need to place some common configuration between the transmitter and the receiver. Before making the connections, you need to make sure that both the X and the RX will work with the same settings. 3 of these settings are the transmission speed in bouts per second, the data length in bits, and how is the start and the stop bit. So let's see what are these. Imagine that you want to send the number before 198. The representation in digital pulses of this would be this one. So with this data we already know that we will send 8 bits. So now we know the data length. The transmitter and receiver must have the same configuration. But if we analyze the UART signal, we won't see only these 8 bits. We will see something like this. That's because UART needs a start bit and an end bit. Usually the UART signal is always high, and the start bit will be represented by a low pulse. So that makes very easy for the receiver to detect when the data starts. Each time we detect a low pulse, we know that we need to start reading the input data. And now here comes the third configuration, the speed of transmission. Without knowing the speed, the receiver won't be able to know when one bit will end and the other one will start, and by that it will ring the wrong value. For that we need to set the speed in bouts per second. A very common UART speed is 9600 bouts per second, That means that the length of the bit will be 1 divided by 9600, and that equals to 104 microseconds. So now all the receiver has to do after detecting the start bit is to count time. We count 104 microseconds and then we are at the beginning of the first input bit. But we don't usually save the value here, because the data is unstable. So we will go in the middle of the bit. So we count 52 microseconds more. And now we save the first bit, and then we count 104 microseconds more and save the second bit, and so on. Once the receiver has all 8 bits, we'll wait for the stop bit, which is represented by a high pulse, and then we can send the received data from the buffer to the rest of the system. This exact same setup could be made with different speeds or different amount of bits for the same data. Usually the start and stop bits are always like this. So that's how the UART communication works.
I hope you understood how what UART works. Okay, UART is a asynchronous serial communication. That's what we are talking. What we need to know? We need to set initially what is the baud rate. Okay, what is the length of a data, and then what is the start and stop bit. Okay, so let's see how we can code that using ARM7 LPC2148. Okay, so this is the LPC2148 what we have. As I told, what is a asynchronous form of serial data communication. So whenever I say asynchronous, it means that we need to have an initial agreement between the transmitter and receiver, right? So what are the things we should know? We should know in the initial agreement, both the sender and receiver should agree on these parameters. That is baud rate, parity, number of bits per byte, start and stop bit. So these things the sender and receiver has to agree. Once they agree, the sender, as you can see here, we have a sender and receiver. So the sender is connected to the receiver and receiver is connected to the sender, right? Rx represents a serial input and TXD represents the serial output. In the LPC2148, we have two ports for the UART. One is UART0 and another one is UART1. In our program, we are going to use UART0. Okay. This is the initial configuration. So initially, as I told, both the sender and receiver has to agree upon certain terms. So this is the initialization code for that particular initial agreement. What is it? Pin select of 0 equal to 0x0005. So what it means? So when we say a pin select 0, it means that we are going to select the port 0 to port 0 from 0 to 15 pins. Okay, whenever we say pin select 0, it means that we are going to select port 0 to 15. Okay, if you use pin select 1, it means that we are going to use pins from P016 to P031. If I'm using pin select 2, then I'm going to use now P1 from 16 to 31. In our program, we have used pin select 0. So it means that we are going to use pins from 0 to 50 of port 0. Okay. So you know that pin select is a 32-bit register. Okay. So we have 32-bit values, but we are going to store only the 16-bit value. So it means that each pin of the port is represented by 2 bits. You can see that port 0.0 is represented by 2 bits of the pin select register, that is 0 and 1. Similarly, pin 1 is represented by bits 2 and 3, 2, 4 and 5, similarly so on. So port 015 pin is represented by bits 30 and 31 of pin select 0 register. Okay, so in order to use UART0 for transmission and receiver, so these are the value that we need to set. So for example, if we want to set the port 0.0 for transmission, then we need to set the value 01 for the bits 0 and 1 of the pin select register. Okay, so for the bit 0, we need to initialize as 0, and for bit 1 of the pin select 0, we need to initialize 1. If we set this, then that particular port is used for UART transmission. So in order to use port 0.1 pin for receiver, we need to set this particular value. Okay, so what it means, here you can see here, if I set pin select of 0005, Okay, this is the hex. Okay, how we can represent hex? We can represent like this. Okay, 4 bits in binary is represented by one hex value. That's why I have color coded so that you will understand. Okay, so what we have initialized? We have initialized to 05. You can see that the last hex value is 5. So binary equivalent of 5 is 0101. You can see that I'm setting this is the pin select register. Okay, so I'm going to set the 0th bit to 1 and 1 bit to 0. Okay, so as explained in this chart. Okay, the 0th bit, sorry, the 0th bit is initialized to 1 and the first bit is initialized to 0, so that the port 0.0 is used for UART transmission. Correct, so that's why we have initialized 5, and for in order to receive this we need to initialize bit 2 and 3 as 01. So that's why we have initialized bit 2. Okay, bit 2 and 3 has 01. So it is nothing but pin select. This is the value 0x0005. So it means that we are going to use the port 0.0 for the transmission and port 0.1 for receiving. Okay, this is the first initialization. And next, what we are doing? So we have done this. So next we are using U0 LCR. So LCR stands for line control resistor. Okay, line control resistor for the UART 0 port. Okay, so here we are going to initialize as 0x83. 0x83, you can see here I have represented in hex value 0x83 and corresponding binary value. Let's see what is that 83. So if I set if I want to use, uh, I need to initialize what all a data length, baud rate, and stop and start bit. Correct. So U0 LCR line control resistor. Okay. So this is used for setting that parameters. So in the U0 LCR, okay, you can see that it is a 8-bit resistor. Okay. So if I set the first two bits of the U0 LCR determines the bit length, character length. Okay, what is the if I send particular data, what is the length it has? Okay, if I set 1 bit has 00, then it means that I'm going to use 5-bit character length. If I set 01, it means that I'm going to use 6-bit character length. In our program we are using 8-bit character length, so that's why 0 and 1 I need to initialize 1 1. Okay, you can see here in this program, so I have used 0 and 1 bit as initialized as 1 1. Okay, so if I make 1 1, it is nothing but 3. Okay, next. So next bit, 2-bit represents what is the stop bit select. So if I use the 2-bit, if I initialize it as a 0, it means that I'm going to have one space between the characters. Okay, one stop bit. If I use if I set it as 1, it means that I'm going to use 2 stop bits. Okay, so this is how we represents the stop bit in the character length, data length. Okay, data. Now we have parity enable. So if I make it a 0, then it is a disable. If I make it is enable, it is enable. Okay, in our program I'm making a stop bit as a 0 so that it uses only one stop bit, and parity I'm making it as 0 so that it is disabled. You can see that second and third bit are initialized to 0. So this is second bit. Okay, second bit is 0 and third bit is 0. And what is the next? This 8 value, let me tell you. Yeah, so this is the 7th bit. So 7th bit, if I make it as 1, so that's why I'm getting as 8. You can see if I make 7th bit equal to 1, I will get 8 in a hex value, right? So why I'm going to what is mean by 1? 1 means enable access to divisor latches. So if I enable this particular bit, it means that I can set the baud rate. Okay, if I want to set the baud rate, I need to make this as a enable. Okay, yeah. So how to set a baud rate? You can see in the code. we can set baud rate by using U0 DLL. So U0 DLL, it is used for setting the baud rate. So in our program, we are using the standard baud rate, that is 9600 baud rate. Okay, so in the hex, that value is 97. You can calculate this baud rate value. Okay, there are some formulas, so you need to calculate the hex value based on your baud rate and the clock frequency. But we are using the standard 9600 baud rate, so that's why it is 97. Okay, there are other baud rates also. Say for example, if you want to set baud rate as 12 no, 1200 or 2400. Okay, we are using the standard one, 9600 bps. Okay, that's what we are setting as U0 DLL. So this we are setting the baud rate. So once we set the baud rate, then we need to disable that particular divisor latch. If we don't disable this divisor latch, then we cannot access the other register of the UART. So that's why once we set the baud rate, we need to disable that particular bit. So that's why you can see in this program, once we set the baud rate, okay, once we set the baud rate, I'm going to disable that particular divisor latch. You can see that now you use 0 LCR equal to 0x033. Earlier it was 83, now it is 03. So how it is 03? So if it is 03, it means that the 8-bit value, you can see earlier 8-bit value was 1. Now I'm going to set it as a 0. So that's what we are disabling the divisor latch so that we can access the other register of UART. Okay, this is about the initial agreement between the sender and receiver. Once we have done the initial agreement, now we need to send the data to the laptop or a PC. Correct. So how we need to send the data? So in order to send the data, first we should store that particular data into some register. So for that we have U0 THR. U0 stands for UART port 0. THR stands for transmit and hold register. So in this register, whatever the data that we want to send, that will be stored. Initially what we are so that's what we are storing the value into this particular register. So here what happens in this particular register, if there is any data, means if still data is sending, then we can check this particular information by using the line status register. U0 line status register, LSR stands for line status register for the port U0. Okay, so if the data is sent, then this particular bit in the THRE in U0 LSR register will be set. It means that it will be 1. Otherwise, it will be 0. Okay. Hence, we can check whether the data is sent or not. Okay. So this is the 8-bit U0 LSR register. You can see that the 5th bit, we are interested to know 5th bit, that is transmit hold register enable. So if this bit, based on this bit, we can say whether U0 THR is having any data or not. So if U0 THR sent all the data, then it will be sent. Otherwise, it will be 0. So in order to check whether all the data is sent or not, we are using this while loop. So we are handing U0 LSR register value with 0x20. So 0x20 corresponds to 5th bit. 2 corresponds to 5th bit. This, for example, you can see that I'm using 20. Okay, 20. So this is 0, and I'm enabling 5th bit. The in a binary, to how we can represent 2 in a binary, it is 0010. It is nothing but 5th bit. I'm making it as 1. Okay, so this value I'm ANDing with U0 LSR register. Okay, U0 LSR register. So if U0 LSR, if the data is not sent, if still the data is there, okay, if still the data is present in the U0 THR, then it will be 0. So 0 and of 1 is 0. So that's what 0 not of 0 is 1. So that's what it will be still in the loop. Once I send all the data, then this particular 5th bit of the U0 LSR will be 1. So 1 of 1 is 1. So not of 1 is 0. So that time will come out of this particular loop. So it means that we have sent all the data from the U0 THR. So this is the program, how to send the data to the LCD, the uh, other device connected to the microcontroller. This is the overall code for the UART. Okay, so as I told, this is the initial. We'll start with the main program. So initially, we are going to have the initial agreement. So I'm going to call this function UART0 initial. Okay, so this will initialize all the parameters. As I told, first we are going to set that port 0.0 and port 0.1 for the transmit and receive. Okay, and then we are going to set the baud rate, okay, stop bit and bit length, and then we are going to set the baud rate, and then we are disabling that particular divisor latch bit so that we can access the other register. What are the other register? U0 LSR, U0 LCR. So these register, if you want to access, then this particular bit should be disabled. Okay, that's why we are disabling. So this is the initialization. Then after initialization, we are going to call the print function. So this is the string that I am going to display. So this will call the print. Okay, and this whatever the string is stored in this particular array A, and for each character I'm going to send put char. So this is the put char function. So for each character I'm going to store that into the U0 THR register, and then I'm going to use this while. So once all the data is sent, so this will become 0, and not of 0 is this will become 1, and not of 1 is 0. So that time it will come out of the loop. Again it will going to print the it is going to send the next character. So until what? Until \0 is happens. Okay, so this is the working of the UART. Let me show the demo. Sir has explained about the logic of code. Now I will explain like how you can run the program. Okay, so once you have written the code, and you need to right click on the source group, and you need to add the file to the existing group. Okay, so since it is already added, so you can see, you can select this, okay, and press add and then close. So already it is added, so that's why I will not add, so I'll close. Okay, you need to add that particular code to the source group. So once you add this, you need to compile by clicking this. Okay, then it will display if there are any errors or any warnings. Okay, if there are no errors, then it will be fine. Okay, code is fine. Once you do the compiling, if there are no errors, you can go for building the target. So once you build the target, see successfully it is built. Now what you need to do is you need to do some settings in order to create a hex file. So I'll explain how you can create a hex file. So first what you need to do is you need to go for the project. Okay, project, yeah. After that you need to select options for target. Okay, once you click this particular option, then options for target, so you will get this pop-up menu. So you need to go for the output. Okay, you need to go and select the output. So this will not be selected, okay, since I already run, so that's why it is showing it is selected, but initially when you run, so it will be unchecked. So what you need to do is you need to check it, so that when you build a target, so hex file will generate. Okay, so this is one setting you need to do. Another important setting you need to do is you need to go for the linker. So once you go to the linker, so this option will be unselected. Okay, so you need to select this, you need to check this, and these are the settings that you are required in order to create the hex file. Okay, then you press OK. Okay, yeah, then again what you need to do, again you need to compile once again, and again you need to build. So once you build, so it will show you that hex file is creating a hex file. Okay, so you can find the hex file in the project folder that you have done. Okay, so you can find the hex file in the project folder. So I have created the folder here, ISC. So you can see that the UART. So in the UART you need to go for the objects folder. So in this object folder you will find uart.hex. So this is the hex file that you are going to run in the microcontroller. Okay, now how to make this uart.hex to run in the microcontroller? So in order to do that, you need a software called as Flash Magic. Okay, so I have installed this Flash Magic, so I will open that Flash Magic. Okay, so this is the software that is used to run your hex file into the microcontroller. Okay, so yeah, so once you open this flash magic, you can see these options. So what is this COM port? So this is the COM port. You have connected your laptop or a PC to your microcontroller. Okay, so once you connect, okay, just look here. So I'm going to connect the USB cable. uh, yeah, yeah, so I have these cables. Okay, one will go to the microcontroller and one will go to the laptop. Okay, this USB cable will go for the laptop or computer system, and this one you will attach to the microcontroller. Okay, so you will, yeah, you will connect to the PC, and here you will connect to the microcontroller. Okay, so once you connect, it will take power from the USB cable. Okay, yeah, so once you connect, first you need to check to which USB device you are connected. Okay, so how to check that? So you can go with which port you are connected. So you can check with respect to, here you go to the my computer, click properties. uh, After clicking properties, you go with the device manager. Okay, once you go to the device manager, you can see ports here. Okay, click on ports. So it will show you to which port this USB you have connected. So you can see here I have connected to the USB serial port COM4. So this is the port that I'm connecting to the microcontroller. So now what you need to select in the flash magic, you need to select the same COM port. So mine is 4. So when you connect your system, so there may be different port. So this is how you need to select. And these are the different settings that you have set, that is baud rate 9600 and oscillator megahertz frequency. So all this will be selected. And another thing you need to remember is you need to check this. Okay, it will erase all the flash code which are already there in the microcontroller. So whatever you are burning, so that will be run on the microcontroller. If you don't check this, then whatever the previous program that is burnt, so that will be running. Okay, so always remember to check this. Okay, and then after that you need to browse the hex file that you have created. So I have created in the ISC. Okay, ISC, and I have created UART. So in the objects, this hex file will be there. So you select and click open. Okay, and click open. Okay, so once that is open, now you can start sending the hex file data to the microcontroller via USB cable through COM4. So I will start. Yeah, so now it is running. So you can see that the status it is showing running. Okay, so once this is running, once it is transferred completely, you can see the output. Yeah, you can see the output in the terminal. So how where you can see is, you should go to the tools. Okay, in that there is a terminal. So you need to select to which port that you want to see the output. So ours is COM4, so it is already selected. So I will press OK. So now you can see that a hello world will be printed continuously. Okay, so the microcontroller is running that program, and it is printing hello world. Okay, so this is how you can run the program. Thank you. So this is how you need to run the program. Okay, I hope you understood. Thank you.